A number of you have reached out to me or to Mr. Wishart, and you just want a little bit more confidence with how to work out these density problems. So I have a series of 5. Watch as many or as few as you need in order to feel comfortable with how to work these density problems, especially when it isn't density that you have to solve for. All right, so let's start with what we know. Density is mass divided by volume. And Mr. Wishart also showed you something that looked like this, which was a circle with mass on the top and then density and volume down below. Now I'm going to show you how this is useful again as we try to work through these problems. Density problems will almost always be in a word format, and we want to run screaming out the door when we see a word problem and just skip over them, but you really don't have to. You solve these in 2 relatively easy steps. The first one is list off the variable letters for what you're dealing with. In this case, we know these problems are density, and we know that the only 3 things we have to know are density, mass, and volume. So before we even start reading what this problem is, we can go ahead and write down the 3 variable letters we need. Step 2 is now read the problem and see if we can identify some different, what the numbers are and which numbers go with which variable. So number 1, a metal ball has a mass of 2 kilograms and a volume of 6 cubic meters. What is the density? Well, this seems pretty straightforward. It's told me everything. The mass is 2 kilograms. The volume is 6 cubic meters. And it literally asked me, what is density? So once I've identified all of this, now I can go to my equation and put my numbers in. My equation is density is mass over volume. So I can simply substitute those values in and solve. And I'm going to come up with 0.33 kilograms per cubic meter as my answer. Right? Now, how does this circle come into play? Well, if you'll remember what Mr. Wishart said, this circle, if I identify in the circle the variable that I'm supposed to find, and in this case, I'm supposed to find density. If I find that in the circle and I cover it up with my finger, or I scribble it out with my pen, I'm left with the other 2 variables in the relationship that I need to deal with them. In this case, M is over V, so I'm going to divide mass by volume. Okay? Let's look at another one. Remember, step 1 is go ahead and identify your variables. Density, mass, volume. And now we can read the question and see where these numbers go. Water has a density of 1 gram per milliliter. So we can go ahead and fill that in. What is the mass of the water if it fills 10 milliliter container? What is the mass tells me that's what I'm going to need to solve for. And 10 milliliters will be the volume of the container. But remember, my formula is this. So I have a choice. I can plop the numbers in and then algebraically rearrange it, or I could go back to this circle. I can scribble out what I need to look for. In this case, I'm looking for mass. So if I scribble that out, I can write mass is equal to, well, what's it equal to? Remember I told you we're left with the other 2 variables in the correct relationship, which means that mass equals density times volume. So now I can plug those numbers in. 1 gram per milliliter times 10 milliliters equals, well, look, milliliters cross off, and then I'm going to be 1 gram times 10 gives me 10 grams. The question is, does this make sense? What unit should mass have? It should have grams, so that checks out. You feeling more confident? All right, let's do number 3. What's step number 1? We write down our variables. Density, mass, volume. We're going to go to the problem. Certain gas expands to fill a 3-liter container. Its mass is measured to be 0.6 kilograms. What is the density? Well, what is the density means that's what I'm solving for. Mass is measured to be 0.6 kilograms, which means 3 liters has to be my volume. So, density is equal to mass divided by volume. So, I have 0.6 kilograms divided by 3 liters, which will give me 0.2 kilograms per liter. Feeling good? All right, number 4, identify the variables. Density, mass, volume. Read the problem. A solid is 5 centimeters tall, 3 centimeters wide, and 2 centimeters thick. It has a mass of 129 grams. What is its density? I don't have a volume. Or do I? Remember, Mr. Wishart showed you this. Volume is equal to length times width times height. Do I have that? Yes, I do. I have a length or a width and a height of 5 centimeters, 3 centimeters, and 2 centimeters. So you have to start recognizing that sometimes in these problems, you may have to calculate a mass, you may have to calculate a volume before you can calculate density. But all of the information to do that should be given to you. So in this case, we're going to have to calculate volume before we can solve for density. 5 times 3 is 15, times 2 is 30. And then centimeter times centimeter times centimeter gives me cubic centimeters. So what I know is the volume of this rectangle is 30 cubic centimeters. And now I can actually solve for density, which is the mass divided by the volume. So I'll take 129 grams and divide it by 30 cubic centimeters. And I get 4.3 grams per cubic centimeter. Okay, last one. Identify your variables. Read the problem. What is the volume of a marble that has a mass of 3 grams and a density of 2.7 grams per milliliter? So again, I'm not solving for density this time. I may need to go back to this circle, right? And remember how the circle works. I'm going to scribble out the variable I'm told to solve for. In this case, I'm told to solve for volume. So if I scribble that out, what am I left with? I'm left with that volume is equal to mass over density. Because when we scribble out the variable, the other two are left in the right proportion. So I can solve this pretty easily. Mass is 3 grams. The density is 2.7 grams per milliliter. Grams marks off. And I'm going to get 1.1. And remember, when you've got a fraction in the bottom of the bottom fraction flips up. So the volume is actually 1.1 milliliters. I hope that these examples helped. And if you still are a little uncertain, just email me or Mr. Wishart and we'll help you out.